So my name is Shubham Shah. I'm working as a senior CFD engineer in ARK Info Solutions. So firstly, we will be going through what's new in Ansys Fluent, and later on we will go with the mechanical and the electronics part. So starting the session with the what's the latest updates or current release, that is Ansys 25 R2. So basically, there are multiple new features which are available based upon the usability, user interface, expressions, boundary conditions, heat transfers, combustions, multi-phase, dynamic meshing, discrete DPM modeling, turbulence, turbo machinery. So these are the different areas where there are certain new enhanced features or new developments have been done. So one by one, we'll be seeing everything in a brief. So coming towards the Fluent 2025 R2 highlights. So basically, GPU solver has got more strong from before. So even the VOF multi-phase and species transport have been enabled. FGM modeling with CST has been enabled. Even you can go with the radiation modeling, that is surface to surface models, that has been enhanced and optimized as compared to the previous release. Then if we talk about the usability and the user improvements or user experiences, so basically Ansys has integrated the Ansys Engineering Copilot in Fluent desktop interface basically. So that also I'll showcase you how to utilize that. What is basically the function of the Copilot, how we can help it out. And then there is a certain enhancements in the GPU physics based upon the battery modeling sites and the aerospace applications and the different workspace, whether it's the meshing part or other parts. So there are multiple enhancements in the latest version. So first we'll start with the usability and the user experiences. So now you can run the batch modes options from the launcher updates itself. So as you see on the launcher update itself, we will be having an option for the batch mode. If you just simply take on this, so there also you will get the three different options if you want to go with only graphics, no GUI, no graphics, and the hidden mode. So based upon the requirement, you can select the best submission mode for the batch submission jobs. Then there is an Ansys engineered co-pilot integration basically. So this is the UI of the 25R2, and then you will get the co-pilot over here. So this is basically your co-pilot which will help you out to understand, or if you are going through any simulation and you are encountering any of the problems and you want to just go through the material, or you want to see what that problem is along for. So for that, we have integrated the Ansys Learning Hub, knowledge materials, AIS forms, and also the Ansys GPT. So which will give you a good amount of knowledge to resolve your problem. So as you can see, it can be enabled through the learning and supporting types. And from here we can Ansys Engineering Copilot option is there. From here we can open it up. And from here we can give a search like what do you want to see. The home option is there, the learning resource and the forum, and also the Ansys GPT option is there at the bottom. So let's say you are working on any of the domain and you are not aware like what share topology is. So you can simply write share topology and you can search for it, the share topology. So this is basically your Ansys GPT. And you can ask your question over here based upon the Ansys existing data. You will get the answer. So how to, for example, here we are searching how to set up a boundary condition. So based upon that, you will be getting the results related to the tool which you are using, with the whether that is Fluent, CFX, or any other tool. Based upon that, you will be getting your answers. You can have a look around it. You can see whatever tutorials or reference materials are available would be there in a single window. So like you see 1, 2, 1, 2, 3, 4, 5, these are the references, and these references are purely based from the Ansys data itself. And these are not the open source data basically. Then annotations have been added in the Fluent post processing. Basically, not in the CFD post, but in the Fluent itself, we can proceed with the annotations. So annotations include your date, time, version, number of iterations, flow times. If you are using any expressions that you can do. So for that, we'll have a quick view how we can do the annotations. So in the view tab, there is a option added annotation over here. From the annotation text, you can select the uh, best option. Let's say you are going with the date and time. So you can select the date and the time. And then there is a number format is also available. You can simply add the date and time in the contours below the basically your GUI, and you can save that image for the reference as well. So in same way, you can add more annotations as well. So as we can see in this uh, video, it's explaining the entire steps how to plot an annotation. So this is basically for the temperature. You can change this from the temperature, or let's say you want to see the pressure or pressure drop. So that also can be, that is also possible. So the current one which we are seeing is for the annotation for the pressure drop we are going to plot, and we'll select the date and time, and then we'll we can rename also. So here we are renaming the annotation text. So that is your average pressure drop. And from the value top end, that we will be changing it to the test one, which we have already created. And then based upon that, we can plot, basically add it to the GUI, and then we can save that. So you can see the average pressure drop of the system is a certain value of the pascals. So in this way, annotation will help you out. You can also give the names, or let's say date and time. Apart from that, if you want to showcase like how many iterations you have done, so that also you can do. You can also add the multiple. So basically, once you have added the pressure drop, and then on top of it you want to add the date and time as well, so that option is also available. So coming towards the other thing is, that is your Q2 plot. So initially we were not able to, in the previous versions, we were not able to play around with the minimum and the maximum axis values, or let's say the distance between the grid. So now that options has been enabled, so we can also zoom it, or we can give the options as per the requirement for the distance between the grid lines, so we can see it in a more uniform form. Then GPU post processing, coming towards the average over monitors. So we can now, when we are running any solution on the GPU, we can write, plot, and print the moving average. So basically, your report definitions can now be plotted in terms of GPU as well. So here, from here, we can see average over, and from here we can plot. So once you plot it, you can also get the dot out files in the working directory. Then coming towards the Y plus bits based heat transfer monitors, coefficient monitors. So this also based upon your Y plus value, how the heat transfer coefficient is varying. That can also be plotted with the dot outlet out file, and this file will also be get saved in your working directory. Basically, generally these kind of simulations or this type of HT Y plus based HTC files are used for the gas turbine combustion. Then coming towards the GPU direct post processing. So this is still in the beta mode. That is the beta feature, and maybe stable release will be there in the next version. So now we can know, plot the node values on the plane surface. So if you see on the right hand side, the earlier, if on the circular places, we can see this is how the contour velocity contours might look like. But when the node values have been enabled, you can see how precise the contours have been plotted. So for this improved display, in the contours option, there is an option called node values that we need to enable it. And from there, we can see the precise and the smooth contour. Then direct post processing, that is also a beta feature, and we can, in direct post processing, we can now plot the ISO surfaces basically, and we can see how the droplet in the ISO surface is performing. So if you see this on the animation on the right hand side, so this is still in the beta mode, but we can use it. So coming towards the other settings, that is your transfer of case settings. So now we can copy and paste the, let's say there are two different fluents open, so we can copy and paste the setup or the result part. We can just simply right click on the mouse button and select copy settings and paste settings option. So basically this drag and drop is available, and copy paste is available. So drag and drop was released in the last year's release, that is 24R2. But for 25R2, copy paste and result node now has been enabled. But solution mode and the setup node is still in the beta version, but the results node, results we can copy paste it. That option is available. We can also evaluate the case settings using exporting the options. Earlier we can only export with HTML formats, but now you can also export the results in the text formats as well, and the PPTs as well, PDFs as well. So this is basically example how we can do. We can right click on it, export to file, and then we can select in the which format we want to do. So this is basically useful for comparing the view. So view in the sense the all the settings and the all the details, the informations which is plotted in that particular contour. So for that we will generally get an outline view for that. Then volume rendering in Fluent has been enabled. So that is basically still in the beta mode, but you can access this through the ribbons only, and through ribbons in the results tab. You can see the in graphics part, and then there is a volumes option is there. So you can plot the volume rendering. Basically, this is how the volume rendering tab will be looking. Once you open the volume one, this is the first tab which will open. Then we can select the second tab. So this is basically for the your transparencies, then the ISO values and the color codings, and this is the final result for display and save. And this is how the volume rendering will look like in the Fluent itself. We can also define the animations. This is available for both desktop interface and the web UI. So we can plot the animations during the simulations. This cannot be plotted for the GPU one, but in the CPU one you can plot it up. So this is how we can plot it. We'll be selecting the appropriate sides or for where we want to plot the animations. Or let's say you're plotting on the plane. So depending upon the requirement, we can set the uh, uh, boundary conditions for that, and then we can simply display it. So we can also play the HFS animations. So like this, the simulation is, you can see the simulation is running on, the solution is running on, and we can also plot the animation and check. So this option is also available for the CPU, GPU, based upon your web interface and the desktop interface, basically. Now coming towards the interactive tool to create multiple planes. So you can also create the multiple surface type of planes from the results tab. So this is one of the example. So how multiple planes at a single go can be created through the web UI, basically. So if you see, if you are moving one, you can also move the other ones. So depending upon the inputs which you have given and the locations you have given, all the three planes will get uh, allotted or get to its directions as directed by the coordinate systems, basically. If I quick forward it. Mesh display option has also now been enabled. So this is also for the CPU as well as GPU based upon the web user interface. Now, when you go into the graphics, so basically earlier what we have to do, we have to go in the display tab and then we display the mesh. But now from the cell zone conditions only, you can select the fluid, right click and display. Once you display, your graphics panel will get open up, and from there we can select by surface, by zones, or the interior portions, and depending upon this, and then we will open this mesh window. So from here we can select the edges and faces and the types, coloring types. So once we display, the mesh will also get displayed from here itself. So this is a quicker process. Now directly adding of the color maps is now also enabled. So let's say earlier we have to go to the contours and then we can play around with the minimum and maximum range, and we can check whether what are the hotspot range. Now if you click on the legend, from there itself you can see we have an option to change the fields. So minimum and maximum values, basically. Measuring distance tool is now available in the select menu. So from here, if you go to the distance menu, it's on the probe, you select the distance, and from here you can see at what distance your components are, or you can select distance between any two of the thing at a probe point. So you just have to select that particular probe and you will see the distances over there. If you select two probes, you can see the distance between the two probes, like what is the distance. So this way you can also see the radius and the diameters as well. So now fast zone merging is also available. So earlier the merging of two different zones or combination of two different zones were a bit tricky and time taking, but now simply right click on it, the zones you want to merge, or you can go to the combine and merge zones and select the two zones. It will quickly merge. So basically the time is lesser as compared to the previous version. And this is available in the CPU mode. Coming towards the expression, there are certain prerequisites for expression. So on running on the NVIDIA CUDA 12.8. So what is options are available? Basically, you can rename the expressions. Basically, once you rename the expression, all the dependencies will automatically get updated. So as you can see on the right hand side, we have renamed it, and all the dependencies on this particular zone also be renamed. So you don't have to rename each and every operation expression linked towards it. When we talk about the large number of expressions, improved speed for the import and the loading operations is there applies to the running Fluent, whether it's a GUI, whether it's in the CPU or the GPU mode. In both the modes, that is available. Certain expressions have been added in the reduction mode. So basically, these are the different expressions which are now available for the GPU solver. So basically, area average is available, mass low area average, pressure force is available, and weighted sum. These are the certain few expressions which are now available in the GPU, or in earlier version this was not available. When we talk about the expressions, so earlier we used to give the turbulence intensities and turbulent viscosity ratio as a certain fixed constants. But now we can also import the expressions or constant profiles and the expressions in this. So for turbulent kinetic energy, turbulent dissipation rate, a specific dissipation rate, we can add constant profiles and expressions, which can vary with respect to time or space. But when we talk about the turbulent viscosity ratio, so turbulence intensity, turbulence length scale, turbulent viscosity ratio, and hydraulic diameter, this can be varied with constant and expression only with respect to the varying time and not with space. Coming towards the boundary condition and solver settings. So basically 3D fan model is now available for the GPU mode. So sample capabilities are added over here, whether it's axial, radial or tangential sources. All the 3D effects of the fan without resolving the geometry is available. So basically this is the 3D cell zone condition. In this direction or at certain inclination there is a fan, and we can see how the fan is going to perform. What is will be the minimum velocity and maximum velocity. Based upon that, you can also plot the fluid flow vectors or path lines and streamlines. Free slip wall condition, basically wall boundary condition is there. So traditionally the boundary condition was of type symmetry, used to consider is a free slip boundary condition. But for planar surfaces, symmetry is an appropriate assumptions. So based upon that, it introduces a small errors on the curved surfaces, right? So that only specified shear stress formulation is available for the GPU solver. This can also be enabled in the CPU solver. For that, we have to enter a text user interface into UI. We have to enter a command line. So this is basically solve set advanced specified zero shear alternative treatments to yes. So doing this will enable. Then what we have to do, we have to keep the zero shear stress components in X, Y, and Z directions as zero to activate this, and we have to select the shears specified shear over the shear conditions. Then transient frame motion numerics is enhanced. So basically it reduces the dependency on the time step size, and the artifacts in the solution. So basically, if your time step size is larger or somewhere around not nearing, so the system will try to not depend on that thing, and it will rely on the frame motion numerics basically. Then coming towards the heat transfer and the radiation. So when we talk about the radiation part, surface to surface radiation model has been optimized. So this is how this is for specifically for the GPU model. So the runtime has been reduced. So in the earlier version, so that is a 25 R1. Thus, we have a comparison state case study of steady state simulation with 1000 iterations, 22.7 million cells, 13 cell zones, and 127 phase zones. So earlier time was a bit slower. The blue one indicates the 25R1 and the 25R2 with 2.2x more speed. So your simulation will get quicker results. Coming towards the surface to surface radiation along with the sliding mesh option is now enabled. So you can see this is one of the results for the sliding mesh along with the radiation model. Radiation heat flux is here, and incident radiation mode is also plotted over here. And with the sliding mesh, we can also perform this kind of radiation model. That is basically with the mesh motion. Then solid motion that is enabled, but that is still in a beta mode, basically used for the disk break sort of analysis where the energy transport is due to the solid motion basically. So this feature is also enhanced or introduced in the beta mode. Then when we talk about the solar load model for longer time spans, so in the earlier previous versions, what we were able to do is solar load calculation was be done in for cannot be done for longer than 24 hours. So basically at night it will you can run the 24-hour cycles, but from the midnight it was not possible to move further. But this has been enhanced, and now you can go with the more than 24 hours of run considering the solar radiation model. So radiation models in the user interface and the Fluents are available. So UI enhancements has also been done. The CPU, basically in CPU you get the P1 model, Monte Carlo model, DO, S2S, solar ray tracing, solar load. But when we go to the GPU, DO and S2S model is available as per the current release. Coming towards the combustion part, the combustion with the adjacent solids has been enhanced for the premix combustions plus CST combustions. Temperature dependent properties of solid can be considered, solves total enthalpy equations in solids, and solid time stepping is now supported. For finite rate chemistry, the speed up improvements have been done. So now this sort of finite rate based combustion chemistry simulations are now up to 60% faster as compared to the previous release. When we talk about the VOF model, VOF and species transport model, this is still in a beta mode. So coming with the variable density framework along with the transient and the steady state sliding mesh, MRF, multiple mixtures, and non-Newtonian fluids. Basically, these are the certain examples. You can see how the mixing is taking up place along with the species transport. So this is still in a beta mode. Again, with the non-Newtonian fluid, this is also clubbed with the VOF model, still in a beta mode. So for evaporation and condensation, the Lee model basically we can add the coefficients by UDF. This is purely based upon the CPU part and not available in the GPU. So including the UDF, you can add the model coefficients. So Hertz-Knudsen pressure-based model improvements are also there. So earlier, what used to happen in when we go with any sort of condensation and or evaporation simulation, evaporation of pure liquid cells were occurring at random temperatures or any temperatures basically. So that has been now avoided and the model has been stabilized as of now. So when we talk about the electric potential or let's say electrochemistry part, so Joule heating has been there with the CPU and GPU. This is basically oriented towards the battery modeling and the fuel cell modeling. So it now supports the couple walls properties defined by expressions and the periodic boundaries. So this is available in GPU mode. Then an equation battery thermal abuse model is there. So this is basically more general and flexible than the existing implements which are available in the tool. And any number of abuse reactions is possible, and more accurate predictions can be uh, observed using the Singh's N equation battery model. So swelling model is resolved with the lithium ion battery model. So extension of the resolved lithium ion battery model with a swelling model. So you can study the novel electrode materials in the modern EV battery applications. That is one way and two way. Both FSI is possible along with this model. So this is only available in the CPU part. So this is another additional enhancement, that is your electrochemical reactions. Considering the porous media is also available. So to resolve the electrode, that's basically your solid phase and the electrolyte liquid phase. The electrochemistry reactions can be taken on a place along with the porous zone. So this is one of the examples for this. Typically used in the flow batteries, fuel cells, and the corrosion or the porous media part. So when we talk about the dynamic mesh, so the new algorithm for the node motion has been defined. So in the old versions or the previous versions, you can see when there is a joint over here, we can see the distorted or degenerative type of mesh. But in the newer behavior, you can see the mesh is not that much regen degenerative. So this enhancement is also available. So this is basically in terms of post-processing for the GPU as well as CPU particles and for the DPM model, basically that is your discrete phase model. And now particle sampling is available for the user-defined planes. And particle sampling was restricted to phase zones only in 25 R1, but this is not a restriction in 25 R2. For the Pi, Fluent, and the Web UI, you can increase the missing DPM models. So LWF is fully covered over here. So if you see, then post-processing has been included for the path lines, particle, tri-X sampling, histograms, DPL sample controls. So everything has been included over this PyFluent and WebUI. When we talk about the turbo machinery, renaming of the entire turbo workflow or turbo setup is available. You can avoid the confusions. And if you see the turbo machineries part here, the turbo setup is there. You can define the your turbo topology. Then fully fast, this is the entire setup for the turbo outflow, and fully faster wheels or the larger periodic sectors than the previous releases, with the copy and the merge options which are available in the turbo setup. And now this is the ability to perform or to take two different meshes in the same setup for the turbo fluent turbo setup basically. So you can see here from the two different meshes, we have taken one of the setups, and the meshes have been taken from the two turbo grids basically. And then the parameterization has been done. So this is for the blade averaging enhancements, still in the beta mode. So this is for the API and the web user interface, more oriented towards the PyFluent. So when it comes to the aerodynamic damping and blade flutter analysis, usability enhancements have been there for the multi-select, create and edit for the dynamic options, and easy switching between the periodic and the phase lag option. This is available in the CPU mode itself and not in the GPU. When we talk about the aerospace time to temperature model has been enabled for the CPU mode and web UI and the desktop interface. So for a custom mixtures, data can also be now used from the Chemkin models basically. So this is one of the examples for the high speed numerics. So on the left hand side, we can see the Mach number. So density based solvers and the two temperature settings are also available in the API, that is your CPU based and the PyFluent basically. Earlier, virtual blade modeler VBM was limited to the number of rotors removed, but now that limitation has been removed. Exposure of VBM in web user interface is enabled. Again, this is not available in the GPU mode. So parametric workflow, design point of view, like design point tables can now be exported to the PPTs form. So all the design which we used to link with the Excel, and then there was certain confusions of the mismatching and all. So that has also been rectified. Now you can also import it into the PDF or PPT format. Also, let's say you are running certain design points like 5 or 10. Based upon that, you are only focused, like you want to see the major focused regions. So you can also narrow down that. So basically, you can filter the plots for based upon the design points. So this is for the entirely for the all the design points, and then now you can see these are for the separate maybe selected 5 or 6 various design points, and you can filter it out basically. So these options are also available. So yes, that was it from the CFD point of view. If you have any questions, we can go ahead. Otherwise, we can go to move to the uh, mechanical part.
Yeah, thank you, Shivam. So anyone if has any kind of doubt, then please type it in the chat box, or they can even text it, or either they can mention their queries in the last at the last of the session. So I'll just share my screen. I hope my screen might be visible to you.
Yes, yes, your screen is visible.
Yeah, so good afternoon all. So I'm Chetan Patil, working as an application engineer for Ansys FEA at ARK Info Solutions. So this particular the presentation will be based upon the Ansys mechanical updates or the particular features those have been newly added to the Ansys latest version, that is 2025 R2. So first of all, we'll go with what kind of innovations that has been done. So in order to cope up with the upcoming emerging technologies developed by the research engineers in industry, and to improve the ease of utility of the software to the new and the even the no old users as well. So Ansys is continuously working on the updates, and in every version, Ansys added various different kind of updates. We'll see some of the updates over here. Basically, first of all, there was the latest version. Uh, sorry, the previous versions, if we are going to discuss about. So the previous version, that is 2021 R1, in which the Ansys motion was added to the Ansys mechanical, in which we can perform Ansys analysis on mechanisms which have flexible rigid bodies, and both for bolt tools. We have dedicated ACT applications and even ACT app extensions. So even activation and deactivations of smooth particle hydrodynamics, SPH bodies, and explicit dynamics was available at that time. So that particular upgradation was done with the 2021 R1 version if we compare it with the previous versions related to Ansys mechanical. Then with respect to the incrementations in the versions in 2021 R2, the Ansys Sherlock was newly introduced in Ansys Mechanical. So it is a new model which provides faster and accurate life prediction of the component systems, component systems in the sense basically electronic component and even the systems and the PCB. So basically it has particularly used to give you and more feasible results related to the life predictions, and finding out the results related to the reliability of the model. So it has also increased the exposure of coupled field elements for sensor designings, MEMs, devices and actuators for automobiles and AR VR as well. So with respect to the version upgradation, they have included lot many number of things. So as you can see, the listed updates related to the Ansys mechanical from the version 2021 R1 to 2025 R1 has been listed down over here. So basically, as we are going to discuss about the latest version, similarly, many more updates are there released with respect to the releases were made with the versions. So as you can see, the listed number of upgradations with respect to the versions, as is as it is mentioned over here. In the similar way, we are going to discuss about the latest updates in the Ansys 2025 R2 version as well. So let's speak about the latest updates in the current version of Ansys 2025 R2. We'll see those in the upcoming slides. So first of all, we'll discuss about the Ansys GPT. So all of you might be known Ansys GPT itself does mean an virtual assistant. So Ansys GPT is an AI powered virtual assistant which is basically built for Ansys product itself. So it helps engineers to understand or either whatever the queries they are stuck with. So the questions they might have. So to particularly give more accurate solutions to the queries that they might face, or either provide step-by-step guidance to them. So this Ansys GPT can help them in those kind of processes. And also it does helps you to particularly it understands the queries related to the ANSYS, basically whether it might be related to mechanical, whether it might be related to any other physics. For example, it might be an issue related to the meshings, the material model, solver errors, workflows, or anything. So ANSYS GPT can give or provide you the particular like accurate resolutions for those kind of queries that you have. So even it provides high quality responses within minutes by searching with respect to the vast database of ANSYS knowledge itself from the forums or either from the ALH ALH database, or either whatever particular materials that might have with it from whatever the experience that ANSYS does has. So it will just search out that particular data and try to give you the most accurate result within just a few minutes of time. So it holds conversation into multiple number of languages, and this is a particular virtual assistant that has been built using the OpenAI service itself. So in the similar way, we do have the Ansys Copilot as well. So Ansys Copilot has now been integrated with the Ansys mechanical tool. So already Shubham did explain how this particular Ansys Copilot does works with respect to guiding you with any kind of problem that you might be facing, or if you want to learn about some new things in the Ansys mechanical software or with respect to the particular simulation that you are working on, then this particular Ansys Copilot will help you with those things and how to launch the particular Ansys Copilot and all. So already Shubham did explain it in the learning it. There is a particular tab in Ansys Mechanical, or either you may consider Ansys Fluent. So there is a particular tab that is learning and support. So you can just access that particular tab and you can try to access the Copilot over here. So the Copilot can be considered to be more convenient to use because this is an AI assistant which is directly integrated to your Ansys simulation products, and there is a particular expertise which has vast amount of database knowledge in it. Then there is particular access guided through this particular Copilot, so where you can find out better learning from it, and even there will be some kind of support that can be provided to you. So basically, if customer is facing some kind of issues related to the simulation, or if there is some kind of particular help that he might need related to the particular problem that he might be facing with. So customers can raise their tickets and even can track their particular support cases over here on the Ansys Copilot itself. And Ansys Copilot does also allows you to particularly make use of the Ansys GPT within that particular platform itself. So below over here in the Ansys Copilot, as you can see, there are many number of tabs which are present over there. So even the particular training materials are available, learning sources are available, Ansys GPT support and all other things are available within the Copilot system itself. So you can just particularly click on those tabs and you can access whatever module that you want to go with. Then talking about the particular licensing and access and privacy about this particular Ansys Copilot. So Ansys Copilot is totally free for every customer. So those who want to particularly leverage the Ansys GPT or either the Ansys Copilot. So those who are already leveraging the particular product, they do have the access for the Ansys GPT as well as the Ansys Copilot. And even there is no particular issue with respect to the privacy, because Ansys Engineering Copilot does not store any particular queries that you are putting over there or responses that you are generating from the Ansys GPT related to your particular problems, or even any model data will not be stored over there. as this is an authenticated app, authenticated particular service, which is particularly authenticated by the Ansys SSO itself. Then now talking about the particular meshing. So what kind of improvements that has been done with respect to the meshing over here in the latest version. So we were previously using the edge sizing option, which was creating issues related to if we are particularly trying to refine some of the local edges on the geometry. So at that time, not just those particular local edges were getting meshed, but even with those particular edges, the particular mesh which was adjacent to that particular edges were also getting affected due to it. So that's why there is a particular upgradation over here where you can find out a new tool that is blend to neighbor. So basically this particular tool gives you a particular access to either enable it or either disable it. If you particularly from the initial whenever we were using the edge sizing in the previous version, the option that was already been available over there, like the edge sizing was available and it was already always being enabled over there. So due to that particular reason, due to just meshing the local regions on the geometry, even the mesh on other particular parameters or the neighbors of the particular edge were also getting affected due to it, and which was particularly affecting the quality of the mesh as well, and this was particularly affecting the simulation results. So what you can in the latest version, they have particularly fixed this problem by providing you an option to enable or disable this particular blend to neighbor through the edge sizing. So as you can see these two particular images over here, when we are using the blend to neighbor option to be yes, which was even enabled in the previous version, how the mesh near to the particular edges was also getting affected due to the particular edge sizing that was locally applied over here. Now, in the latest version, when you are using this particular option to be disabled, the particular mesh will not get affected over here. So basically, when this particular tool is enabled, the measure consider the size of the elements on the selected edges and adjacent adjust the sizing on the directly connected edges or either the surfaces to create a gradual change in the element size, as you can see in this particular image, which particularly affects the density of the mesh itself. So this particular method does helps you in preventing sudden changes in the mesh density, which can negatively impact simulation accuracy as well. So that can be done with respect to the latest version. So there is an improvement with the contacts as well that we were using previously in the previous version. Whenever we were trying to generate some kind of contact, even if there are many multiple number of contacts, those are sharing a single surface itself. So we used to create multiple number of contacts over there. So this particular proximity detection group has been generated newly to particularly detect those contacts which are being generated for just similar kind of surfaces. So as you can see in this particular image which is shown over here, the particular like the initiation of this kind of feature which has been generated over here was particularly to group the contact by particular faces or edges. Those are having similar kind of contacts with respect to the particular different geometries. So this helps in particular contact reduction and constraint cleanup. So as you can see in this image as well, so this is a particular PCB geometry which has several different number of small components which are mounted on the same kind of geometry, that is a PCB laminate. So there are total 221 number of contacts those were detected previously with respect to the previous version. So in this particular model, basically with respect to the latest version, as you can see, all the number of faces those were in contact with this PCB laminate surface has now been merged into a single contact itself, and now just the total number of contact has been reduced to two number of contacts over here. So this particularly helps you to reduce the number of contacts as well and remove the overlapping constraints in the geometry, which particularly stabilizes the convergence issues as well, and even the particular equations those are getting solved in the background. Now coming to the particular composite part, basically this is the ANSYS composite QR simulation, which uses the RTM solver basically, which is the resin transfer modeling solver. So this particular ACCS RTM simulation has been particularly developed in such a way. So now the particular RTM solver runs faster, and the software can read the results more quickly over here. So this reduces total simulation time and speeds up the post-processing part, like even when importing the temperatures from other simulations. So basically, we were facing issues related to those. So ANSYS now gives you the particular access to thermal import, which is now provided higher priority than internal thermal settings basically. So this ensures the temperature imported temperature data is being correctly used over here, and which provides consistency to the overall model. Now you can even transfer the particular degree of cure over here. Basically, this degree of cure is the particular added support which we call to be newly invented over here for the RTM solver. Basically, you can transfer the degree of cure, that is how much amount of the resin has chemically been hardened over here, from the RTM simulation to the ANSYS composite cure simulation. So this allows more accurate thermal and structural analysis results during the curing process. Then later on, coming to the particular topology optimization part. So whenever we previously used to perform the topology, so we used to not control how the topology should be generated for a particular region. So as you can see in this particular image over here, so if we are interested in only generating a particular optimization in the region that is being highlighted over here, so you can even control those particular optimization of this region through the new tool that has been invented over here, that is extended control tool. So basically this particular tool is named as the local design restriction tool. So which helps you in particularly optimizing the shape that you have selected over here with respect to the constraints, like either if you want to particularly optimize the overall geometry, the region that you have selected over here for the optimization process. So whether you want to morph that particular geometry in both the direction, that is in the inward direction as well in the outward direction, so that the particular selected nodes on the faces over here can be moved or can be displayed in any direction that they want, but you can control the particular displacement of the node during the optimization process over here through this local design restriction. So you have the particular option to select the number of faces on which you can apply this particular control on, and you can define whether what kind of morphing that you want to allow over here for the optimization. So as you can see particularly how the morphing is being done, if you are selecting these number of faces, if we choose the outward kind of morphing option over here, then if we are selecting both morphing option, that means we usually call this both as the free morphing option. So both means free morphing of the selected number of nodes on the defined faces to like limit defined to this particularly limits the defined nodes for the displacement. Basically, whatever the number of nodes that we have selected through the face selection over here, this particularly provides a limitation to it, which controls how much amount of optimization should be done on these particular nodes which are present over here. So that can be even provided through this optimization option over here. So the total move limit can be controlled, and which is currently set to be program control, and these kind of results have been obtained through that particular simulation. So all these three options are available. Even more number of options are available along with direction and all. So those can even be applied through the local design restrictions over here. In the similar way, for the different process, like for the forming process over here, you can use the same kind of local design restrictions over here. Either it might be an outward morphing, inward morphing, or a free morphing. So how does this particular morphing does takes place over here? On the image you can see how this particular free morphing does gets generated in the geometry, and this particular free morphing is controlled by the particular total move limit over here, which has been program controlled. So you can even define the particular constraints, like what amount of nodal displacement should be done. So that has been defined over here, and you can see how the particular morphing is being generated in both the directions. So this is about the inward only. So you can see how the particular morphing does only takes place in the inward direction over here. And this is for the outward. So basically, this way you can particularly optimize your models with respect to the extended controls. Then we have the particular optimization with respect to the multi-material topology optimization. So this is a modern feature that allows engineer to design components using combination of material within a single simulation basically. So to achieve optimal performance like such as superior fitness to weight ratios, and basically, or if you want to go with specific material property distributions. So this particular method does helps you a lot with those. This approach is particularly relevant for designs produced via the additive manufacturing process. So the primary goal of this MMTO, basically this multi-material topology optimization, is to determine not only where the material should be placed, basically, but also which material should be used in specific locations to meet the design objectives and constraints over here. So as you can see, the overall geometry which was present at the initial, that particular geometry has been optimized, and you can provide a new material over here that can be utilized with respect to the particular actual material that was defined to the geometry. So you can create this particular multi-material optimization tool using the structural optimization method over here itself, where you can find out the new tool, and you can define the materials that you want to use for the optimization process, and the amount of particular filling method can be defined over here, and the solver will automatically decide which particular region should be defined with what kind of material over here. So this way you can develop a multi-material optimization on any kind of geometry or any kind of material that you want to use with. So Fluent is also applied over here. So that's why you have lot many number of gaps in the overall geometry, which particularly doesn't affect the strength of the overall geometry with respect to the boundary conditions. And even it doesn't particularly like affects the stresses or the deformation generated on the body as well. So even the weight reduction is also been a prior condition that we are trying to simulate this problem for. So after that, we have a particular optimization method that has been newly introduced over here. That is user-defined commands over here for temperature optimization, where you can now only select the temperature conditions itself for the optimization method. You can provide the temperature criteria, which can be directly used and which is now supported for the optimization process. And this particular constraint can be defined through the UDC, that is user-defined commands for particular temperature optimization itself. Now coming to the particular dynamic simulations. So basically whenever we are solving a dynamic simulation, so this is the particular new feature that has been introduced over here, that is automatic mass proportional damping. So this is new ANSYS feature which automatically adds a small amount of mass proportional damping only where it is needed during non-linear or either contact heavy simulations. So as you can see this particular problem over here, where there might be large amount of fluctuations within the particular iterations over here. So this particular method adds some small amount of mass to it so that it won't particularly create some kind of issues for converging the model, and there won't be larger amount of amplitudes in the overall geometry. So wherever it is required to add up the mass on the particular simulation, so it will keep on adding the mass. If it is not required in some of the regions, then it will automatically remove the mass from the geometry as well, which is particularly used to achieve convergence without loss of accuracy. Then we have the another mesh optimization method over here, where you can make use of the particular command msh opt. So basically this is a particular mesh optimization command over here, which automatically adjusts the mesh refines or either the refining or either the coarsening of the meshing over here, which wherever different materials meet with each other, so you can get a cleaner and more accurate kind of interface over there. Even it supports embedded line and reinforcing elements, and now also embedded shells and membranes over here. So previously, whenever we were generating reinforcements within a concrete body using the particular beam elements or either line elements over there, so at that time the particular mesh was getting optimized in those regions, but over here now it has also refined with respect to your particular like shell elements and even the membranes as well. So as you can see, wherever it is required, you can just insert the mesh optimization command over here, and it will automatically refine that particular region wherever the interface is getting created. And if it is already been refined over there, then it will also help you with coarsening that particular region over there. So this is a particular optimization tool that has been introduced over here. Then kind of joint that we usually are interested in finding out, or we want to particularly apply such kind of joints for the simulation of kinematic and dynamic problems. So in multi-body simulation, basically several rigid and flexible bodies move and interact with each other through the help of the joints. So these joints control how the body can move, like hinges, sliders, or ball joints. So how these particular bodies can move can be controlled through these kind of joints over here. Sometimes you need a particular, you need to provide a particular rotation to happen around a specific axis itself. So to provide that particular rotation around a specific axis itself was not possible with the previous versions. So that's why a new joint has been introduced over here. That is a rotation axis based Gen C joint. So this allows you to define that exact axis. So the rotation is accurately modeled over here along the particular line. So these kind of joint can be even used for particularly defining a rotation axis based through this particular Gen C joint. Then coming to the non-linear mesh adaptivity and material removal. So this is a new feature that has been introduced over here. So you can particularly see this particular feature is only applicable for 2D analysis itself, and it only supports static and quasi-static kind of simulations. So this kind of non-linear adaptivity of the mesh and the material removal from the overall geometry is only supported for 2D simulations with static or either quasi-static procedures, and also all type of materials are particularly supported for this non-linear adaptivity framework. Then even there is a particular void that is getting created over here for the removal process of the material. So that particular removal process of the material is generated through the elliptical void, and that particular elliptical void can be created single for per substep. So basically only a single void will be generated on the material over here, so with respect to the substeps that we are creating to solve this particular problem over here. So if I would play the animation, so you can see how the particular like non-linear adaptivity of the mesh is getting generated, and you can see the voids those are getting created between the geometries over here. So those voids are only supported to be created per substep over here in a single manner. Then coming to the particular fracture simulations, so the fracture parameter, that is a particular module which is available in the fracture, that is smart crack growth with cyclic symmetry. So this is a new particular combination that has been introduced over here, that is smart crack growth with a combination of cyclic symmetry. So previously cyclic symmetry was not allowed to be used with the smart crack growth option. Now it has been combined with each other. So ANSYS can simulate crack growth using the static or fatigue as well in models that use the cyclic symmetry. So during each remeshing step, the software automatically keeps the matching mesh on the cyclic faces and updates the cyclic constraint equation. So symmetry remains valid as the crack grows in the overall geometry. Then then even there are some kind of limitations with respect to the cracks generated on the body. So crack cannot cut into cyclic boundaries. That means the matching mesh that we have generated on the surfaces. So on those regions, this particular crack cannot be generated over there. And even there are some kind of limitations with respect to multi-stage and single stage as well. Then coming to the another parameter for the fracture, that is fracture parameter calculations with mixed mesh. So previously ANSYS like was not allowing to make use of the mixed mesh. So now ANSYS allows fracture calculation, that is stress intensity factor or the J integral, etc. Even when the mesh has mixed element types or either mixed orders over there. So uh, Guys, please turn off their mic. Yeah, okay. Okay. So as I was mentioning about this fracture parameter, so which allows now the mixed meshing as well. So ANSYS allows this fracture calculations for SIF, that is stress intensity factor, J integral, even when the mesh has mixed element types or mixed orders in it. So this means you can insert and grow cracks even in older hex dominant models as well. That is the legacy hex dominant models, which were not available for the current versions, but now they have newly introduced these hex models that can be particularly used with remeshing your particular geometry for generating a cracks over there or fracture over there. So this particularly helps you to reduce computation efforts when crack grows in such mixed meshes, and making the analysis faster and more efficient with respect to such kind of improvements. Then talking about the resource prediction, basically they have invented some kind of modifications in the chart of the resource prediction, where you can extend your particular number of core visualization on the graphical screen to 128 now. And even there is a particular XY scaling for the log to log and log to linear kind of scaling that can be done with respect to your particular resource prediction chart. Then coming to the solver, basically, the PCG solver has also been enhanced over here to particularly make reduction with the memory usage, and even has improved the particular robustness of the particular solver. So if we would compare it with the previous version, then how much amount of improvement with respect to the memory reduction and improve robustness has been done is mentioned over here. Considering the turbine benchmark problem, which has lot many number of degrees of freedoms present over here, nearly equal to 1 billion number of degrees of freedoms, which was using a PCG solver. So this particular concept was using a non-linear static analysis, which has lot many number of contacts in it. So using 1 billion number of degrees of freedom, the amount of number of cores, if we are using the amount of memory usage has been mentioned over here with respect to the versions. So if we would compare with the 2024 R2 with respect to our previous version, that is 2025 R1, there is a lot amount of difference between the particular version upgradation itself. So how the particular PCG solver is enhancing with respect to the version incrementation, you can see it over here through the number of cores and the memory usage plot over here. So this particular plot was with respect to 1 billion number of degrees of freedoms, which was used for these PCG solvers. So now if we compare the same kind of 1 billion number of degrees of freedom, but for a different kind of problem, where non-linear static analysis itself was being performed, but with inclusion of all the three types of non-linearity, that is plasticity, geometry, non-linearity, and the contact non-linearity as well. So basically these kind of problems does takes lot amount of memory usage with respect to the course. So that particular number of cores, if was listed with respect to the previous version, is mentioned over here. Now with respect to the upgraded version, how much amount of particular reduction has been done with respect to the memory usage has been mentioned over here. So this does helps in larger kind of complex problems, not for the smaller kind of simulations. So coming to the particular material upgradation or the material features over here. So we have a particular material property, we can say. So ANSYS now supports generalized brittle damage as well, which lets you to simulate cracking and breaking in the brittle materials. The damage is triggered when the maximum principal stress, basically the maximum principal stress exceeds a limit of brittle fracture behavior. So these kind of simulations can be even now can be particularly simulated using the properties through the material can be defined over there. And these kind of properties have been newly added to particularly visualize the brittle kind of behavior of the models. So viscous regularization has also been added uh, to particularly enhance the stability of the brittle damage simulation. So this particular viscous regularization is added to keep the simulation numerical stable and avoid sudden solution jumps over there. And considering this into simple steps, it models brittle breaking more accurately and runs more smoothly without instability. Then talking about the particular hyperelastic material, basically, so there is a particular AI assisted initialization has been done for the combined material models. So wherever you used to use make use of the experimental data to particularly curve fit those, so you can see the experimental data when we were doing the manual setting with respect to the initial parameters for curve fitting, and with respect to the fitted parameters we were trying to analyze the particular model. So how the particular AI has assisted in such kind of initialization to curve fit the model has been listed over here. And as you can see, the particular AI assisted initialization outperforms manual parameter settings. So this particular setting has been done with respect to the like this particular study has been done with respect to some kind of case studies. So this does lets you know how particularly AI has outperformed the manual settings of the initial parameter to your particular experimental data. So this model is now applicable for hyperelastic material plus chrono series plus shift functions as well. So these kind of material models can also be used with respect to the AI assisted versions now. Then solving performance has been improved for drivetrain gear. So whenever we used to particularly do the simulations of gear for the previous model, so now it has improved its particular solving time with respect to the new versions. So ANSYS has improved the calculation methods as well. So which were previously being used in the derived train gear analysis. Because of this and because of this particular enhancement, the solver runs faster and most efficiently for the problems related to your particular external, internal, and planetary gear systems. So over here, as you can see, the comparison between both the versions. So basically, if we just consider the gear contact which has been generated for this kind of model over here, there is a particular 6.6 times of time reduction that has been generated, which has been listed over here. And if we compare the overall model simulation where there might be many number of different contacts and gear settings that has been done over here, then even still the particular overall solution time has been reduced by 3.5 times through the overall simulation time if we compare to the previous versions. Then coming to the improvements of the cable elements which are previously used for multi-body simulations. So ANSYS has upgraded their cable modeling in the multi-body simulation. Basically, multi-body cables and closed loop cable systems are now supported over here. So as you can see, multi-body cables with closed loop is also available, where you can preload your particular cables with respect to the particular parameters like free length and preload. So you can define a preload to your particular cable that you have selected over here. These are in their beta versions as of now. So those are not fine like particularly launched over here. These are just in the testing phase. So still these particular conditions can be used for your particular multi-body cable simulations. So you can see how the particular closed loop of cable does works, and how there is a particular make use of non-uniform size of mesh for the cable elements over here. So you can even in the previous version, the particular itself, if you are considering as a cable, was being considered as the overall spline. But now if you are considering the similar body for the simulation over here now, you can make the divisions of the overall model as many number of parts as you want to make it. So you can define these particular divisions to your particular cables as well over here. Then new extraction option for the force reaction on the surface plane has been generated over here newly. So you can even plot the force reactions on the surface planes wherever you want to select. So that particular extraction has been included to your particular post-processing part of the force reaction, where you can select only nodes on the surfaces option to particularly visualize the results on the particular surface that you are interested in. Then later on, to create the section plane. So basically section plane can now be created based on coordinate systems itself. Uh, so that has been developed over here. So you can create your section planes based on the coordinate systems as well. And even through the scripting as well, you can create the section planes now. So there is a code snippet that has been mentioned for creating the section planes. Then section planes, whenever we create a section plane, you can even apply the hatch line display option to cap the particular section plane surface over here. So that particular option has been newly launched over here to particularly cap the faces that has been particularly created the section plane on. Then coming to the LS Tana part, basically there is a particular material improvement that has been done with respect to the material properties. So the particular material has been shortened with respect to their names over here, and they have been listed with respect to their numbers. The particular material number has been added in front of them, so you can particularly make use of the material with respect to the numbers mentioned in front of them. Then now particularly LS Standard does also allows you to particularly make use of the import option. So you can particularly import the external models from the ANSYS LS Dana input file to the ANSYS mechanical to simulate the ANSYS explicit dynamic simulations. Then coming to the ALE part. So basically in LS Dana, SALE, that is structured ALE, has new and shorter keywords over here that make the input file cleaner and easier to write. So basically you don't have to make use of such tabular datas over here now. So whenever you are using the first line command, that is the first keyword defines group of materials in a structured ALE mesh using one compact keyword instead of multiple long number of blocks over here. So whenever you will turn on the particular option to make use of the SALE keywords, so this option will get turned on and you can write such compact kind of input keywords over here. Then post processing is also allowed to be done in the ANSYS mechanical post processing window itself. So whenever you are trying to do this post processing of your particular battery or EM, so that can be done in the particular post processing part of your ANSYS mechanical itself. So you can access the worksheet of the ANSYS mechanical to post process the result related to your battery models. And these are some examples like how the post processing part related to the battery models can be done. So coming to your particular AM, that is additive manufacturing. So this particular additive manufacturing does also allows you to do the mechanical scripting, that is mechanical APDL scripting for defining multi-material builds over here, which is currently in a beta version. So you can define multiple number of material models over here to particularly simulate and particularly create a mechanical APDL script to define different material properties and heating parameters with respect to different regions. So you can see how the particular variation in with respect to the different region with respect to different material can be defined. So that is only allowed through mechanical APDL scripting and is not present in the GUIs. So over here, you can even define the different material properties and heating parameters at each layer and at different regions. So that's all over here from the ANSYS mechanical part. So coming to the ANSYS electronics, so Shubhendra will explain about the updates which are present in the currently latest version of ANSYS EM.
So, hello
So
everyone.
over.
If you have any queries regarding NC's mechanical or NCFD, so for that you can drop your queries on the chat box. I will go with the electronics phase. Just a sec. Can you confirm if my screen is visible?
Yes, it's visible.
Yeah, it's visible.
So, for the already Shubham and Chetan already told you about the latest trends in the 2025 R2 about the safety and the mechanical part. Now I will go through the electronics phase. So there are some of the highlighted points where we have included DC points errors in the HFS 3D layout, prism solver in the HFS 3D layout. When we are talking about the direct GPU acceleration to increase the simulation time, for that also sparse direct solver is used. In SI wave, far field simulation is improved. In the previous versions, far field simulations was not directly into the SI wave. Now, coupling it with the HFS 3D layout, we can directly plot the SI wave, far field plots in itself in the SI wave. Then when I talk about the whole workbench, electronics workbench, so for that Cloudburst is included for all the 3D components. So I will start by one products. So first product when I'm talking about is HFS 3D layout. In HFS 3D layout, we have included Q3D DC solver mesh fusion era. So using mesh fusion, we have computed the DC points. Basically, when in the previous versions, HFSS uses frequency domain, which don't solve the DC points. So for that, we have included the Q3D DC solver in the our HFS 3D layout. For that, the you can use directly with the boundary conditions and directly set up your starting point and ending point, and it will help you accurately define the starting points when you will enable the Q3D DC solver. So for that, the whole mesh settings will be enabled. So one more big changes in the 2025 is band capabilities. When we are going through the flexible PCB models or flexible models, so for that we have included a rigid flex workflow improvement, where when definitions are introduced. When you are talking about, you have to go with the boundary conditions, adjust the boundary, all the boundary conditions you can do. You can, when you are going with the interference shield layers also, like if you are improving going with the EMI EMC analysis, and for that also translation support is there. When you have translated your MCAT model to the ECAT part. So during the translation in the previous versions, there are some things which was lost. So for that, we have included our EMI seed layers, which correctly help you to translate your MCAT model to the ECAT. So yeah, you can see that this is how basically it works. So this was your original designs. So using the footprints, which is now visible itself in there are the two components here. Just a sec. Two components here. One is BGA and the other was chip model. So for in this, you can see that for chip model, all the footprints are visible here, and you can directly see those footprints on the original designs also with the encrypted layout components. So enhancement in the five plus measure. So this is basically for beta versions. So here, when we are importing your whole PCB models, so all the components, all the uh, ECAD files, all those components are imported here. And now using the 5 plus meshing workflow, our efficiency and accuracy is increased in the updated version. Now, when I move to the HFSS version, so this was for the HFS 3D layout. And when I move to the HFSS, so in HFSS, a PC backing part is enabled. So when we were enabling the port, when we were designing a port, so when going with the lump port or model port, so in this, the PEC backing which was defined, it was not enabled in the previous versions. Now in the 2025 R2, you can directly enable the PEC backing to override the issues you're facing during the enabling the port. So one more enhancement which was for the array designing. So when we are the few problems which are facing, like when we are moving to the large array designing, so there was some issues in the store element patterns, or you are going with the beam steering type of things. So for that we were facing the problem. So in the new versions, it has been improved, and it can for you can directly improve the performance of the large arrays, and with the proper beam steering and all. So in this, you can see that these are the basically overall our piece array design. In this, here you can see this is our radiation pattern, and how this our accuracy and this is basically 10 cross 10 patch antenna. So how this our gain plot is, you can visualize with each theta angles. So you can see that itself in this example. So now snapping tool is available. You can see in this, yeah, we can snap from the internal and outer both parts. So this in the video you can see that it is how you can enable this thing. Directly click on any points you want to snap, and you can directly click on the points, whether it is inside the array or outside the array. And proper antenna array placement is enabled here. So triangular lattice visualization is available. So you can see what is triangular lattice visualization. So basically there is like those or the those antennas were basically on the same phase. Like there's a 10 cross 10 or so. Here you can see that we have now defined the other components type of things, like this is 3 cross 2 or 2 cross 3, or you can go with a 5 cross 2. So easily understand and plot the layout patterns. So triangular lattice visualization in the antenna arrays is enabled in 2025 R2. When we are moving to the unit cells, so in the 3D component our library itself, our some of the components are enabled, which was basically in the 2025 R1 or 25 R2, it was not there. So you can use those components also. So net visualization is there for each, like when, like just for example, if you have enabled imported a PCB in the model. So when you have imported that PCB, you can in the previous versions you were able to visualize the those nets in the 3D layout, but not in the HFSS. But in this newer version, you can visualize those in the HFSS itself. So layout components with usability enhancement is there. So like this was basically for the component library, sorry, 3D components. So now for layout components also, there is a one our enhancement introduced. You can directly browse any layout. If you have layout component, you can browse those and you can import that in itself in our model. You can show like you are using, but you want to show all the layout components. You can show that. If you want to hide some of the our component layouts, you can also do that in the new enhancements. So these three are the all the like all type of meshing which will be covered. So first one which we were talking about with the boundary conditions or the conformal mesh or the convex hull. All these three are possible now itself in our HFSS. So sparse directory solver is used. So using this CUDSS solver, we have reduced the simulation time. So now the speed which you are like you are performing some simulations now, you using this solver, sparse solver, you can directly reduce the simulation time. And when I talk about the HFSS SBR plus enhancements, so in this, like a VRT simulation is introduced. So field visualization is there. So you don't need to do anything. Just modify those in the basic steps. You have to go with the minimum, giving the maximum frequency, defining the ray density, maximum number of bounces. Then at which point or which like distance or anything you want to launch your model, so you can directly launch those. And in the advanced section you can directly give the synthetic current sources. So accordingly with your all the VRT plots, your VRT sub parameter will be enabled, and it is basically parametric animations. So for each distance and each timings and at what distance we are visualizing, those all things are possible now with the parametric animations in the VRT footprints. So this is one of the examples where we are introducing one vehicle which is moving all around the system. So this tells you like how this SBR plus solver is increasing with the new updates. So this was for the HFSS. Now, if you are moving to the SI wave, So in SI Wave itself, we are like coupling with the HFS 3D layout is now easier. So like if you are performing some scripting through the scripting or any type of things, so you can directly couple it with the HFS 3D layout, and you can visualize those ready, if you want to visualize far field patterns or near field patterns, you can visualize that in the SI Wave. Now SI Wave far field simulation is supported in the HFS 3D layout, which was where basically directly you can couple from the SI wave to the your 3D layout, and you can visualize those far field patterns. And there's a one more enhancement in this, that DCIR power tree enhancement. So the DCIR was basically for coupling your EM data to the thermal data. So for that also now with the part like sorry for particular placements or particular placements of the your each components, so for that you can directly enable like a thermal challenges, and you can directly couple your SI wave with the ice pack using the DCIR solver. So these are the some of the general improvements, which was basically as well AC DC merge is improved. You can directly now couple Q3D solvers, and you can directly enforce the casualties. You can you can assign the IBs models to the SI wizard, which was basically few of the customers who are facing problem about that. Now it is improved in the new model, so you can directly couple your if you are importing some of the register or some microcontroller. For that, you can directly couple the IBs model to the SI wizard workflow, and you can view the net layer selections also. So these are the basic some general improvements which was improved in the SI wave. So when I talk about the circuit part, HFS circuit, so for that there are multiple EMC tool components. Coupling, decoupling, network components are improved. So you can directly use these for your EMIMC applications. So these are the some of the you can directly now add your power electronics components. You can directly add speed up. Yeah, you want to speed up your simulations, you can directly do that. You can directly like go with the solution options. You can go with the giving the minimum resistance, whatever you want. You can directly in the circuit simulations, you can do those. So AI-driven models is also enabled in our 2025 R2, which was for the beta versions in the 25 R1, which was given we will improve in the 25 R2. It was improved in 2025 R2. You can directly spy some models. You can import itself in our Nexim circuit. So overall, when I talk about the whole workbench model, so for that, the cloud burst components is there. If you are doing some job, now you in between you want to stop those job and then directly move to the cloud sections. You can save your models here, and after sometimes you want to generate those results, you can do that with the help of cloud bursts. So you can with the help of the our models ADT workbench, you can directly couple those, compute those cloud bursts. You can directly use already Chetan and Shom told you about the Ansys Engineering Copilot, which is basically you can directly couple it with the our model. So these are the for ADT workbench part. Now for the thermal sections, so there are some improvement in the ice pack also. So for that, you can if you're working in the classic ice pack, so you can directly import those TZR components and snapping controls in itself in our ADT workbench. You can accelerate your GPU models for increasing the decreasing the speed simulation time. If you are enforcing meshing capabilities are also improved here. So these are the some of the basic which was I was talking about. So TZR import, which are TZR basically a classic icepack file, which you can now import itself in our 2025 R2. So there's some GPU solver supports which enables the which increases the simulation time. Sorry, decreases the simulation time and increases in the accuracy. Thermal mesh fusions you want to go with, like mesh fusion basically deals with there are some layers, there are some internal components, all those components combining. So generating the mesh is little bit high, like difficult. So for that we will use a mesh fusion which will include your all the models. So thermal mesh fusion is included. So there are some of the additional features which I was talking about. So dynamic thermal management, snapping tools, vertex, like VTS. Vertex are basically like covering each components. Like there are some edges which reflect. So taking those things also in our simulation, those things are called vertex simulations. For that, this was all from electronics phase. If you have any queries, you can ask.